This video introduces some of the components that you can use in C# Windows programming. Also, it talks about the application's lifetime and how to customize an application context. This is the overview of this lecture. First, I talk about components, and I classify them into two groups of visual versus non-visual components. The non-visual components appear on the non-visual design surface of Visual Studio, while the visual ones appear on the form in the design window of Visual Studio, as I'll show you later. Visual ones are like buttons and radio buttons. They have some visual view, but the non-visual ones like dialogues, timers, background workers, error providers, and tooltip are going to be are not going to be visual all the time. Sometimes they get visual, sometimes they don't. Some of them, like background worker, they have no visual representation. And then I'll talk about applications, especially how to manage an application lifetime by extending application context class. Let's define what a component is. A component is a class that implements the iComponent interface. The iComponent interface is located in the system.component model namespace. To give you a better understanding of what a component is, you can think of all the items available in the toolbox of Visual Studio as examples of components. You can drag those and drop them on your design tray in the design window of any form that you're designing. In this case, as you see, I have placed two labels, one error provider, two text boxes, and two buttons, one OK, one cancel. When you're designing a form in Visual Studio and you're basically dropping multiple components on it, some of the components will appear on the top, like the text boxes or the buttons or the labels, but some of them, like error provider and tooltip, appear on the bottom. That's the non-visual design surface, which is a component tray holding different components that have no visual representation, like background worker, all the standard dialogues like open file dialog or color dialog or print preview dialog, so on and so forth. There are various components that appear in the non-visual design surface. Some of them, like error provider or tooltip, show their UI infrequently. That's why we don't place them in the visual design surface. For example, as you see here, the tooltip appears infrequently, only in some situations. Also, the error provider here appears only if something happens, just to show the user or get the attention of the user about some error that can happen, that has happened. Also, some other components that are in non-visual design surface, they basically are represented by the creation of an entire window, like all the standard dialogues, open file dialog, save file dialog. And because of that, you don't need to place the components or have visual representation for those components or place them on a visual design tray. They will appear in a non-visual design surface, and once in a while when you try to open them, they will pop a new window up, and that window will let the user select something special, and then the dialog get closed when the user press OK or cancel. And some components like background worker and timer, which appear in the non-visual design surface, do not have any visual representation. Background worker is used to create a new thread and to work on a time-consuming task. in parallel with the main thread and report its progress to the main thread. We'll use this in the future homeworks. Also, timer do not have any visual representation. It's only used to show the time and ticks once in a while. And after the timer ticks, you're going to do something special about it. So we'll use timers also in the future homeworks frequently. Now let's talk about application lifetime in WinForm application, basically in C# Windows programming. A Windows form application starts when a main method is called, just like any other program. The main is going to be the beginning of the program. However, to initialize a Windows form application completely and start it routing Windows Forms events for different control objects, you need to invoke application.run in one of the three following ways. The first way is to simply call the run with no argument. As you see in this code, I just simply said application.run and I didn't pass any input parameter to it. Although calling the run method with no argument is fine, however, it's going to put some burden on some part of the application to call the application class exit method when they want to close the application. For example, when the main form is closing, you need to explicitly mention that we're going to exit the application. You have to explicitly say application.exit. Otherwise, the application won't exit and you have an application with no main form. Because most of the application has only one single UI thread and they have a main form, when closed, the application has to close as well. They decided to create an overload of the run method that takes one argument, and that argument is the main form. When the main form closes, the whole application exits as well. Also, when the run method is called in this way with the only argument equal to the main form, the application begins by showing the main form. Here's the example of second way to call the application run. Instead of passing no argument, we're going to pass the main form object to the application.run, and this way application begins by showing the form and application ends when the form is closed. In order to understand the third and last way to create the application by calling the application run method, you need to understand how the second overload of run, which was receiving a form, operates. Basically, behind the scene, the run method creates an instance of the application context class and uses that form as the main form of the application context. Application context is a class, as you see in this picture, that detects the main form closure and exits the application whenever that closure happens. As you see, it's a normal class. It has two constructors. One gets no parameter, one gets a form, which is the main form, and it has the main form and tag as its properties and an event handler for thread exit. As you see, it has some methods, some events, some properties, and some constructors. Here is the third way of calling the application.run. As you see, first we can construct an application context. In this case, I just made it very simple. It's a new object of application context. I use the constructor application context that gets a new form. I pass a new main form object to it, and that context becomes the input parameter of the run method. So that's the second overload of the run. To summarize, we had three ways to call the run method. One is without any input parameter. That wasn't the best. The second one receives a main method, the main form object, And the third one gets an object of the application context. This third one is the most versatile one, because you can basically customize your application context in a way that I'm going to explain in the next slide. Let's see how we can customize the application context. And to do this, what I'm going to do is I'm going to create a new class. I call this class timed application context, that derives the class application context, right? It derives from the application context. So timed application context is an application context. And in this subclass, what I have done is a creation of a timer. And basically, I have made sure that the constructor of this application context gets the form that initializes the main form of the application context, which is the base class or the superclass. And also, I have handled the tick event of the timer using timer tick method, which looks like this. In this one, I have opened a dialog, a message box. It's not a dialog, it's a very simple dialog. It's a message box that shows, okay, to charge your credit card, time's up. You need to pick yes or no. If you pick no, then it's going to close the main form. Otherwise, it's going to let you continue. So basically, after every 5 seconds, as you see in this timer's interval is set to 5,000 milliseconds is equal to 5 seconds. After every 5 seconds, I'm going to tell the user, are you want to, time is up. I'm going to tell the user time is up. Are you okay to charge the credit card? If it says no, then I'm going to close the form, right? This is like a simple example. You can customize your application context in any way you want. Of course, after you do this, after you do construct this class, you can create a new object of timed application context. And because an object of timed application context is an application context, you can pass it to the run method. And this way you can call the application.run method and begin your program.